In this video, we will be focusing on the geometries, materials, and the grid in the simulation. If the simulation you're trying to build involves geometries like cavities, satellite dishes, waveguides, etc., it's a good idea to make sure those features get included in the simulation next. A powerful feature of vSim is the ability to import geometries originally produced in 3D CAD software like SOLIDWORKS or Fusion 360. vSim supports the import of common file types like STL and step files. In this case, we can import the hand STL file into the simulation. To import an STL or step file, right-click on Geometries and select Import Geometries. Here you can navigate to the STL or step file that you wish to import and double-click it to import it into the simulation. When you first import a geometry, it is likely that it won't fit inside of the default grid. In this case, vSim asks if you would like to resize the grid to fit your new geometry. We recommend that you say yes to this dialog box, although we will be adjusting the parameters of the grid later. At this point, it's very hard to see our geometry and the grid because everything's so large, so we can click Reset Position to make sure everything fits in the screen once again. And of course, turning off the grid allows us to see just the geometry that we imported. Keep in mind the units of the CAD model that you import. This hand was made using units of millimeters, which is a common default for SOLIDWORKS environments. To make sure our hand is actually in meters, we can scale the hand by a factor of 0.001. To do that, we select our hand geometry in the tree view, and under Scale, change it from 1 to 0.001. Once again, it's hard to see our hand, and our grid is likely too large. So if we right-click Grid, we can resize it one more time, and click Reset Position to make sure everything's in view once again. We will also translate our hand using the X, Y, and Z translation values to make sure the origin of the simulation is near the palm of the hand. This just helps later set up in the simulation. Here we have used the values of 0, 0.02, and minus 0.037 to translate our hand. Next, we can create the bones that will go in the hand. This simulation used 5 simple cylinders to represent each finger. A cylinder can be added to the simulation by right-clicking on CSG, Add Primitive, and Cylinder. Selecting the cylinder, we can see all of the parameters that define the cylinder. We can change these values to have the cylinder represent a finger. At this point, I've added all 5 cylinders to the simulation representing each finger. Turning off the CAD model, we can see all 5 of these fingers: the thumb, pointer, middle, ring, and pinky. All the values set for each finger can be found under the properties. Next, we need to add materials such as bone and muscle to our geometries. vSim comes with a few common materials such as silicon, sapphire, and alumina, which can be viewed by clicking on the materials database here. Unfortunately, bone and muscle are not going to be included in this table, so we need to create our own custom material file. To create a custom materials file, we need to create something that looks like this. Here we specify the name of the material, the kind, in this case dielectric, and some properties of the materials themselves. Formatting the file this way, all we have to do is save it with the same name as the simulation itself. In this case, I've named my simulation Wi-Fi in hand, and I need to give it the extension .vmat. Saving this file in the same location as our simulation, like so, we can load this file into our materials database. Simply right-click on Materials, select Import Materials, and navigate to where you saved your VMAT file. Selecting it will import your new materials into the materials database for you to add to your simulation. Select both of your materials and select Add Simulation, and now you should see both your materials over here in the tree. To apply these materials to your geometries, simply navigate to your geometries, and under each one, select the material you would like applied. For the hand geometry, we can use muscle. Next, we need to set up the grid that our simulation will run on. The grid is very important because it defines where our fields will be evaluated in the simulation. To configure the grid, expand the grids tree here and select grid. Again, if you want to view your grid, you can check this box here. In a previous video, we defined all of the constants that will help us define the grid now. Selecting the grid, we can see all of these values that we need to set. We can set these values to a constant by right-clicking and saying Assign Constant. In this case, we want to assign the grid x min. We can repeat this for each of the values for the grid. Finally, our grid and geometries should look something like this. We have our hand STL file imported, all of the fingers represented as bones inside of the hand, and a grid encompassing all of our geometries. In the next video, we will cover some of the physics that is needed for this simulation, specifically boundary conditions and applying current sources in the right locations. We will also look at some of the histories we will need to capture the physics of the simulation.